Okay, fine. So now we will go with some another method. So you can use the conventional approach also, so it understands basically how the elimination approach works. So this is K1 element 1, K2 element 2 in this way, and this is K8, and we have the somewhere here node 8. Okay, so it just doesn't make any difference how do you label it, but if you label it sequentially, it would be great. Okay, so for element 1, so you can create. Okay, so K1, K2, all values are given to you. So how do I go? Now I use K1, K2 for this. So therefore I use K1 bar is equal to K1 1 minus 1 minus 1 1. And for element 1, so let's say this is node number 1, this is node number 2, 3, 4 I have, 5 I have, 6 I have, 7 I have 8. So for element 1, it will be 1 2 1 2. Similarly, K2 bar will be equal to K2 1 minus 1 minus 1 1, and for K2 it will be 2 3 2 3. K3 bar would be equal to K3 and 1 minus 1 minus 1 1, and from connectivity table it will be 2 3 2 3. Similarly, I have K4 bar will be equal to K4 into 1 minus 1 minus 1 1, and for K4 bar it will be 3 4 3 4. Similarly, K5 bar will be equal to K5 1 minus 1 minus 1 1, and it will be 3 4 3 4. Likewise, K6 bar will be equal to K6 1 minus 1 minus 1 1, and you have 3 4 3 4. And then I have K7 which is connected to 5 6. So K7 bar equal to K7 1 minus 1 minus 1, and it is connected to 5 6 5 6. Okay, no, K7 is connected to 4 5, sorry. It is connected to 4 5 4 5. Next is K8. K8 is connected to 5 8. So K8 bar equal to K8 1 minus 1 minus 1 1. It is 5 8 5 8. Then I have K9 is equal to K9 bar is equal to 1 minus 1 minus 1 1, and K9 will be 8 7. Okay, so 8 7 8 7. So problem here in this case is element has to be called always from lowest node number to the highest node number. Okay, but in one dimension it is not going to make a difference, so we'll keep it as the 8 7 8 7. So if your node number are not sequentially connected, this is what is going to be problem. So instead of that, we will change it. So while solving, it should not make any difference. So I call this as a 6, 7, and this is 8. So 8 is connected to now 5 and 6. Okay, and now 9 is connected to 6 and 7. Doesn't make any difference, but 7, 8, then you have to identify the element, so it will not go sequentially. So that creates a problem. So it is 5, 8, 8, 10. 1 minus 1 minus 1 1. So 5 8 5 8. Okay, now from this you can have the global stiffness matrix K equal to 1 2 3 4 5 6 7 8. Okay, so assemble this, okay, and post a photograph of this. So you can take a snapshot, those who have joined late. So this is what is the problem we are solving. Okay, now we have prepared the individual elemental matrices. So we can go this way, or we can go always with the potential energy approach also. Okay, when you use the potential energy approach, naturally your solving time will be lesser as compared with this. Okay, and that is why I always recommend, if such type of problem is there, you use potential energy approach and get the solution, no issue. If you go by this method, so there will be so many elements, and then you have to go for assembly, so it becomes 8 by 8. So anyway, let's have a practice. Okay, and give me a global stiffness matrix. So you can start doing assembly. 1 2 3 4 5 6 7 and maybe 8, something like this. So K1 minus K1 minus K1, K1 plus K2 plus K3, then maybe minus K2 minus K3 minus K2 minus K3 K2 plus K3 plus 3 plus K4 plus K5 plus K6. Then I can have this as minus K4 minus K5 minus K6 minus K4 minus K5 minus K6. I have K4, K5, K6, and then I'll be having a K7 of course plus. Okay. Then minus K7 minus K7 K7 K8 K10. Okay. Then so now I want a 5 6. So in this way you keep on doing it. I just lost it. 1 2 3 4 and fifth row. 1 2 3 4 5. So I got 5 5. I got 5 6 I want. So minus K8 of course. So this will be minus K8. And then I want 6 6. So 6 6 will be K8 plus K9. Okay, so I just don't have a space. Now you can rest of the thing you can write down. And now since 1 is fixed, so you can eliminate the first row and the first column. Then you have 7 and 8 fixed, so you can eliminate 7th row and 7th column, likewise 8th column and 8th row, and in this way you will have the global stiffness matrix and you could solve it. Okay, so I hope you have understood the strategy to solve this problem. Just let me know so we can start with new problem if you have understood this, because it is going to take a lot of time. So I just want to have that whether you have understood the strategy of solving the problem or not. Okay, so if you want a new problem, just type new, or else we will stick with this. Okay, fine, no issue. So now we'll take one simple problem again. Okay, and we want to solve with both the approaches, elimination as well as penalty. So 100 square, area 50 square, and let's apply a force of F here. Just I put it F and I write F equal to 10 kilonewton. And E to be 2 into 10 to the power 5 Newton per square. Let's consider length to be 500 each. So we are not going to have some different length of material. And let's try to prepare it. Okay. So I label this as a node 1, this is as a node 2, and this as a node 3. Okay. So I say K1 is equal to A1 E1 by LE1 1 minus 1 minus 1 1, and that I supposed to get A is 100, E is 2 into 10 to the power 5, L is 500, sorry, 1 minus 1 minus 1 1. Okay, so what I do, I keep 2 into 10 to the power 5 divided by 500 to be common. So 2 into 10 to the power 5 divided by 500, so I get 400. Okay, so two zeros are gone, so I get 1000 divided by 5 is 200, 200 into 2 is 400. Okay, correct. So I can write this as a 400 and I can take 100 inside, and I can write this as a 1 and 2 from the connectivity table. Similarly, I can prepare K2 as A2 E2 by LE2 1 minus 1 minus 1 1, and that I can directly write as 400 50 minus 50 minus 50 50, and from connectivity table I can write 2 3 2 3. Okay, so I hope you have taken this. Okay, fine. So I'm going to scroll down. So my global stiffness matrix K will be 400. So it will be 100 minus 100 minus 100 150 minus 50 minus 50 50 0 0 1 2 3 1 2 3. Okay, so this is my global stiffness matrix. Now from this I can write KQ equal to F. So the next is KQ equal to F. That is what is my FEM equation. So 400, 100, minus 100, 0, minus 100, 150, minus 50, minus 50, 50. And my Q's will be Q1 value is 0, Q2, Q3 is also equal to 0 because this is fixed at 1 and 3. And I just applied a force of 10 kilonewton here. Okay. Now I'm going to use elimination approach. Okay. So by elimination approach. So what happens here in this case? The first row, first column, second row, second column will get eliminated. And sorry, not second row, third row and third column. So what is left is 400 into 150. Okay. So I'm not going to eliminate it because I require this for the penalty approach. Okay. So this row is going to eliminate it. This column is going to get eliminated. Okay. Similarly, this row is going to get eliminated and this column is going to get eliminated. So what remains is the only 50, 150. So 400 into 150 into Q2 is equal to 10,000, and from this you could get the value of Q2. Okay, so you can have that calculation and just let me know this value, please. So has anybody got the value? Okay. So 0.1666 mm. Great. Now same problem we are going to solve by penalty approach. So remember in the examination, watch carefully these two words. Sometimes they say use penalty approach. Okay. So first target is to find out the C. So largest value. So this is equal to max of Kij. I will use 10 to the power 4. So to ensure that my calculation is easier. Okay. So you can use this value to 10 to the power 2, 10 to the power 6, anything. 10 to the power 5 will give you higher accuracy, and 10 to the power 6 very difficult to do it with manual calculation. The most easiest and convenient way is 10 to the power 4. So max Kij is 150. So 150 into 10 to the power 4. Okay, so therefore so this is 400, 100 plus 150 into 10 to the power 4 minus 100, 0, minus 100, 150, minus 50, 0, minus 50, 50 plus 150 into 10 to the power 4, and then I'll have the Q1, Q2, Q3, is equal to 0, 10,000, 0. And now you can solve this by Gauss elimination method. Remember, you have to use this in examination. If you don't, so whatever the marks from this, you will get 0. Gauss elimination approach not. It's a method. Okay, so currently you can use your program, and now I am interested in knowing the value of Q1, I am interested in knowing the value of Q2, and I am interested in knowing the value of Q3. So just use the program and try to provide me those values, please. Okay, so I'll write it down these values. Zero point 40,111. Okay, it should not be non-zero. Huh? That is what is the most important thing. And whatever this value is coming is correct, and this is point, how many zeros? 5 zeros, and then 555. Okay, so mm you have to put the unit. Great. Okay, I just would like to share you few things. So I just share. Okay, so can you see a Chrome? Please let me know. Are you able to see Chrome browser? Yeah, fine. So here you can, this is the vlabs.iitb.ac.in/vlabs. Here you can click on this vlabs dev. Okay, so this is our college forum. You can have explore approved labs, and you can have numerical method lab. This lab is designed by me. You can go explore, and you have the simultaneous equation Gauss elimination method. You can get into simulation. In simulation, these options are there. So you can have 3 by 3, 4 by 4. You can put the equation here also, and you can solve it, and immediately you will get the solution. So you can use this as a calculator purpose. Okay, that is what you can do it. Okay, of course. So this is also you can use as a calculator. Fine. And you can also check out the VLabs dev team page also, where you can see many of the people from our colleges are reflected here. Okay, so that lab you can use it, okay, as a calculator. So now we are going to go with what you say, finding the reactions. Okay, so now for this I have to use first row to find the reactions for the elimination approach. So from the first row it is 100 into q1, that is 0. Okay, q1 is 0, minus 100 into q2, and here the plus r1 and plus r3 will be there. Okay, so that I missed out, so please add it. Okay, so this r1 and r3 are the reactions, so that has to be there. I put it 0 0, so it is 0 plus r1, 0 plus r3. Okay, and